Oke. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi washabihi ajma'in. Rabbi zidni ilman warzuqni fahman. Okay, student, good morning. Welcome back again to our class statistic and data analysis. And today we meet at the sixth meeting. And the topic of our discussion today is the distribution of sampling. Okay, let us first discuss what is sampling. So sampling is come from the word of samples. And sampling is the process of taking samples from a population. I have discussed with you previously. For example, we have a big circle as a population. And then a small part of population you take out is samples. Samples. Sample. So a small proportion of a big population is sample. And the process of taking the sample from each population, it's called sampling. Sampling. The process of taking samples from a population. Okay, then because we take off a sample from its population, then the sample should be representative. Should be representative to its population. Because we take it as a sample, and remember this, that a sample should be a representative of its population. Or we can say, in other words, that a sample should show the actual state of the population. Okay, if a sample cannot follow this condition, then it is not a good sample, a bad sample. Bad samples are wrong, wrong sample. If you have a sample that is not represent your population, okay? And samplings you can do by this method, random sampling. And what is random sampling? The meaning of random sampling is that each member has an equal chance of being selected. So here we have like the meaning of fair, fair. In Arabic, we call adil, adil, fair. What is fair? That each member has an equal chance of being selected. And in our life, the God, Allah, also give us this fair condition. Each of us has a possibility to go to the heaven, and also each of us has the same possibility to go to the hell. So it is a meaning of random sampling. Okay. And we have also two conditions of population, that is finite and infinite. Finite for a small population, finite, small. Or we can say like limited, limited. And for a very big population, we have the condition of infinite or unlimited. Unlimited. Try to remember this, So you know, to improve your English, you should know like the different vocabularies from for the same meaning. For example, we have infinite, and infinite are the same as unlimited. Okay. And when we have the infinite condition, of course, when we have a very big population. Okay, so now we understand about sampling as the process of taking samples from a population, and then the requirement is that the sample should be representative or show the actual state of its population. And to have this, we should follow the method of sampling, that is a random sampling. That means we make the process of taking samples or the process of sampling as fair as possible. As fair as possible. It is a very important point. As fair as possible. Why? Of course, to avoid the subjective propose, to avoid the subjective. In research, you should follow the method of objective, not to follow your desire, but to follow the facts or the condition. Okay. Now we continue to the next slide. We will see firstly about the distribution of a population. Okay. And what is it? It is also about probability. So our discussion today is very connected to our last discussion about probability. All events, the God create for us is a probability, an opportunity to us. And this opportunity is also, we should be happy that the opportunity is always positive. There is no negative probability or opportunity. So it is always with a positive value. And to measure the population centralization, we can use the parameter that we know already as mean or average. To measure the population centralization. So if we have a population, and what is the central of this population? That is the mean value or the average value. And we can also see or measure the population distribution. And what is it? We can use the parameter deviation or standard deviation or variance. Both of these represent the population distribution. From where? Of course, from the mean value. So I will draw for you to improve your understanding or to press back your memory. We have the data. For example, I put the chart. We have the data. This is the data we have. Each dot represent as the data value. And then from this data, we can measure or calculate the mean value. Let's say we have then the mean value here. You have the mean value somewhere here. This line is mean value. So what is the meaning? The meaning is that the central of this data is here at mean value. So this is y, this is x. For each x, you have the value of y, and of course the mean is the central, or means not a very high value and also not a very low value, but in average, in the middle. That is mean. That's why we call this as the population centralization, because the position is in the middle. If we change this to be a normal distribution chart, remember that I also explained you previously that the peak of the chart would be exactly the mean value here, the mean value if this chart following normal distribution. The peak of the chart, the data distribution, exactly its mean value if it is follow the absolute normal distribution. And then, how is the population distribution? We can use standard deviation or variance. So if you want to see what is the standard deviation, what is the standard deviation? You need to calculate the distance, the distance between each value to the mean value. So you see, we have so many value, a distance, a difference. Distance is a difference. Okay, this one is the distance. Some value we have above the mean, some data we have below the mean value. So we will have the difference or the distance between each value to the means. And we calculate this as the standard deviation or variance. If you remember this, look to this formula, you will always have the difference between each data to the mean value. That is the I draw for you how is the condition. So I hope you get understanding about this. From this definition, then we can say, okay, the population distribution should be understanding by the parameter of standard deviation or variance value. Sorry, I want to find eraser. Eraser. Okay. And now let us continue for one example. Okay, I want to ask you first. Do you understand what we had discussed? Do you understand? Or you miss everything? We
As
can
far
repeat.
as you explain, I guess I can take the learn. I mean, I'm understand, ma'am.
Okay, can you repeat, Kisvia? Do you understand?
Uh, I'm understand. As far as you explain to us, I understand.
Alhamdulillah. Okay, good. Please remind me if you miss, or you cannot understand, you cannot follow. Just talk and I will repeat it, okay? And
Okay,
I'm
ma'am.
trying to speak as slow as possible. I can, but maybe sometimes I make it very fast. You can just remind me to speak slower, okay? Okay, now we look to the example we have. We have data. What data we have? The grade of 5 students in statistic, for example, and the members of the data is 70, 75, 80, 80, and 90. So all together we have 5, And what we can do to this data? First is try to tabulate this data. Look here, I have table for you. X, who is X, is 70, 75, 80, and 90. So after tabulating, we can see that we have 4 member, 4 member, 4 X value, 70, 75, 80, and 90. And now we can calculate the probability of each member. Okay, how we calculate this? Actually, we can put the first column, for example, F. I will add for you here F, the frequency F. Okay, and then you see we have 1 times 70. We have 1 times 75. We have 2 times 80. We have 1 times 90. Okay. If we sum up the frequency 1 plus 1 plus 2 plus 1, we have 5. It is called as n equals to 5. Okay, sorry, because we have we discuss about population. I should put here capital N. The number of population is capital N. We have N equals to 5. Okay. And now what is probability? We learned that the probability of X would be the frequency of X divided by N. Okay. So we can use this approach to find this. Oh, the probability of 70. That is the frequency of 70 divided by total events. Yeah. Okay, then it's 1 over 5. And 1 over 5 equals to 0.2. 1 over 5. Just multiply by 2 over 2. You get 2 over 10. And 2 over 10 is very easy to change to be 0.2. Okay. In English, yeah, I have to change this to be point, not comma, point. Okay. I will change later for you. And then all together we have 1 over 5, 2 over 5, and 1 over 5. And if you sum up this, the total of probability, you will get 1.0. Okay. So you get this, yeah? We learned this from our previous meeting. And again, today I want to show you that when we talk about the data, we calculate the frequency of the data, then we can, at the end, calculate the probability of that value. Yeah? Okay, now we go to calculate the mean of this population. Yeah? We have this normal way to calculate that the mean mu equals to, you can put like this, the sigma I equals to 1 until n of x I divided by n. So then you have xi, x1 here, x2, x3, x4, x5. Just put, you remember, your data, and then sum up, divided by the number of data, and you get the value. Then we call this value as mean or average. Yeah. Yes. You see here 79. Yeah? 79 is somewhere here. 79. Yeah? 1 lower than 80. So this is the central value of your data this time. Yeah? Okay, now you have the value for mean. Yeah. And what is the value for example, standard deviation? And always, before you can calculate the standard deviation, you have to calculate the mean value. Why? Because you see, the formula of standard deviation, you need the mean value here. So even the question, for example, I don't ask you what is the mean value. You should calculate the mean value. If I ask you directly to what is the standard deviation value. Okay, look here. The formula of standard deviation is the root square of sigma I equals to 1 until n from the differences between xi to mean value. And you should square it, power of 2. Why? Because some value you have like above mean. So when you calculate the differences, you will find like a minus value, and by power it to 2, you can how to say, you can change the mean value to be positive again, that is the approach, I think, to make it positive. So minus times minus will be positive. Positive times positive, of course, positive. But minus times positive times minus will be minus. Okay, so it is a very interesting relation that if you have minus times by minus, you will have a positive. And at the end, I will not show you of using Excel because it use our time. You can try by yourself to put its value. How is it? 70 minus 79, power 2. Add by 75 minus 79, power 2. Until 90 minus 79, power 2. The total of this then divided by the n value we have, and then don't forget to find the root of this, the root of this value, and then at the end we will have this value 6.63. So then we can say that the condition of our data, from this data, we have the mean value is 79. The deviation value would be plus minus 6.63. Okay, like that. And how we can calculate this relation from the centralization and this distribution? We can write as mu plus minus deviation. What is mean? The mean is the rank of this data is from 79 minus 6.63 until 79 plus 6.63, okay? So it is called the rank of the data. How we know the rank of the data? After we know the deviation of the data, okay? So it is very important to know these two parameters, average and also the deviation. Okay, remember that we can find every time we have the data, we can calculate the mean of the data and also the deviation of the data. And these two parameters is very important. One represent the centralization value and one represent the distribution value. And now we continue to the distribution of sampling. Remember that sampling is a small part of population, but we want that a sample can represent its population. So we can also calculate the mean of the samples. And for example, we put the notation of X bar as the mean of samples. And the value of this, of X bar, is also a random discrete variable. That's why then the mean of X bar has a probability, the same as population, okay? And the distribution on sampling is the probability distribution of a sample of X because of this relation. I will add N here on. But not on. Sorry. This should be off. Okay, let us continue. The distribution of sampling is the probability distribution of samples X. Okay, I will show you later. And the statistic parameters include, of course, the first one is mean as centralization distribution. And then we can use deviation and variance as the distribution population, the distribution value. The centralization value is mean. The distribution value would be the deviation and variance. And we can also see the next two parameters, that is median. Median is the value that is actually in the middle of the population. Sometimes the median can be a mean, but sometimes it is not mean value, okay? And then modus. What is modus? The value that appear more frequently than other. That comes more than one times, more than other data. For example, in our last example, we have 80 as modus because 80 appears two times, while 70, 75, and 90 only appear one times, okay? Then the modus would be 80 in our last case. So remember these 5 parameters: means, deviation, variance, median, and modus. Okay, now we continue from our previous example. We have 70, 75, 80, 80, and 90. Now to play with samples, so we change our previous data. First step, we put code for each data. For example, 70, the code for 70 is V, the code for 75 is W, and we have the code for 90 is Z. So then if a sample consisting of 3 values and is taken without replacement, then we can make a new sample as a combination 5 with a ratio of 3, from 5 with 3. I will put here for you. In this case, we have the numbers of the sample is 5. And we want to make the combination of 3. So the ratio, the R value is 3. Okay. Now we can have like this. Remember this? We can use this like n factorial divided by r factorial. Sorry. Okay, here I will put bracket. The difference between n and r factorial, okay? So we have this. So if we calculate this, n equals to 5 and r equals to 3, we will have here 10 combination. You can try with your Excel sheet. You can calculate also conventionally because it is a low value. It is very easy. Here is the combination, the 10 combination that we just calculated. We have 10, 4, 5, 6, 7, 8, 9, 10. So we can have this combination. How we can try to find a new mean of samples? Just put then its value. Oh, you have V as 70, W is 75, and X is 80. So you have the combination of these three. And now you can calculate the mean of this first combination as 70 plus 75 plus 80 divided by 3. And then you get a new mean that is 75. Following the same rule, you will have also now 10 value of mean of the samples. Okay. So our new data is now this from our experiment. Yeah. And now again tabulated the data we have. So you have 75 and you have 76.67. You have 78, 80, 81, 83. Okay. You have here, you see 6 value from your tabulation. Oh, 5, sorry, and 6. And now calculate the frequency of the data you have. Oh, I have 2 times 75, only 1 times 76, until the end, and altogether you have 10, the same as combination we have before. And now you can calculate a new probability of mean of the samples here. For 75, you have 0.2, 0.1, and the total of probability is always 1. Remember, the total of probability always 1 or 100%. This is very interesting. From this data, we can continue then to calculate the mean of samples. The mean of samples. I have X here. The mean of sample. The mean of sample. X. And we have the mean of population. The mean of population. Okay. Remember, the mean of our population previously is 79. And now we want to calculate how is the mean of our samples. From this, of course, you multiply this, 75 plus 75 plus 78 plus 76 until this, and then divide it by 10. Oh, again you get 79. The value is exactly the same as your mean for your population. So then we can say that the mu of samples equals to the mu of population. Okay? And it is already stated by Mann and Lecker in 2011. The mean of the sampling distribution of X is always equal to the mean of the population. So remember this, and you should believe this. If you cannot believe this, try to calculate again with a different example, different problems, okay? And then if you already find the same, just remember this statement. That is the way of studying, After you study some things, you can prove it, or your teacher can prove it for you. Then believe that. Like I want to say to you, if we are a Muslim, we have, if you become a Muslim, you have to believe in God. What is that? That is La ilaha illallah. Okay? No gods. No God is zero. Illallah. But Allah. Only one Allah. No God. No God. So 0. No God. But We have one Allah. Okay, only remember this. And you should have this. You believe this, hold this. One time, maybe in future, someone asks you to say, uh, to change your belief. Don't believe in your God, believe in my God. We have, for example, they said maybe we have so many gods, and they make the God from a big a plate to a rod, and you have to pray to that God, a new God. Someone force you to change your God. If you have a strong belief, you will not change, even they kill you. That is it. So today I prove to you that the mean of the samples is equals to the mean of population. So we can believe to or use this statement for every case in future. You should believe it. Please believe it because I prove it for you. Okay. Then up to you to believe or not to believe. Okay. But I recommend you to believe about this. In your statement, we can make this as a law, hukum ya, a law. Okay, that is the way of thinking. It's very simple. Okay, student, do you understand me? Or you want to ask some things? Please.
No, ma'am, we are understand.
Clear, yeah? Okay, so remember this law, yeah? The mean of sample distribution is always equal to the mean of the population. Okay, now we continue to the method of random sampling. It should be random, okay? Because it is a very fair method. Each member have the same chance to be selected, okay? So the method of random sampling, we have two methods. What is that? The first one is without replacement. How is without replacement? For example, I collect your name. I put in a paper and I roll it, and I put in the bottle, and I how to say, I shake it, and we want to select one of you. Just take one of this after shaking, Okay, and then we know who will be selected, We know already. And we want to select the second time. I shake the second time. If the one we select previously, is not put back to the bottle, it is called without replacement. That means on the second shake, the one who already selected before cannot be selected anymore because we didn't put back the name of the person to the bottle, okay? That means without replacement. The selected sample cannot be reselected. The selected one cannot be reselected again, okay? And the second one is the with replacement. That means the sample can be selected more than once because we put back the name that we have, okay? That is the way. And in random sample, the each member are dependents. Xi are the independents. Independent, that means free. Each xi follows a probability function, and then we can find the number of combination as this formula that the combination of this is the n population, the number of population, n capital, and we have also a small n, small letter n, as the number of samples. So remember that. N capital is the number of population, and n small letter is the number of samples. And now we go back to exercise to improve our understanding. Let's say in this exercise one, we have the number of population 2, 3, 6, 8, and 11. So altogether we have 6 members. Then we can find the mean and deviation of this population following the formula we have. The mean is, what is the mean? The mean is 6 mile to 1 until n of xi divided by n. Okay, so I have to put the correct one. Here is equal, should be here. Okay, and also the deviation. With the same formula we have previously, the deviation is should be the root square from what? Yeah, from sigma I equals to 1 until n, from the difference between xi to the means and power of 2 divided by n. Okay, so we have this, and we can have the key answers. The means equal to 6 and the deviation equal to 6.29. Okay, continue to exercise 2. Still this, from the same population, consists of 2, 3, 6, 8, and 11. Now we want to take examples from our measurement. What is our examples? Now, if you want to use 2 measurement result as samples with the measurement result as follow. Oh, we want to use 2 measurement. So remember, if we use this 2 from 5, you can calculate like 5 combination from 2. You will have here also 10. So here you have 10. The combination of 2 and 3, 2 and 6, until 8 and 11. Okay, 10. Now you have the data. Okay, calculate the distribution of the samples. How we can calculate? Remember from our previously example. Of course, try to find the mean value of each new samples we have. So here we have the mean. What is the mean? 2 plus 3 divided by 2, 2 plus 6 divided by 2, 2 plus 8 divided by 2, until 8 plus 11 divided by 2. So you will have a new mean. Then calculate the distribution of that. Okay. Now, the first step, always try to tabulate the data. So you have the mean here for each data, and then you can calculate the probability. And here is the chart of this probability. For all of them, you have 0.1, only 0.2 for the mean of sample at 7. Here. Okay, you have here. Okay, now try to calculate the next, the mu x. And remember here, if sampling without replacement or limited condition, we need to calculate the standard deviation of samples with a correction factor. And what is that? The correction factor is the root of difference between the number of population and samples and the degree of freedom. Something -1 is degree of freedom, df. This always, the formula is n minus 1 or n minus 1. In this case, the number of population, the degree of freedom of population. But for the mean, we have already the law that the mean of the sample is always equals to the mean of population. So we have no problem here. Only in the case for the standard deviation, you should remember this. In the case of without replacement, please multiply or make times to the correction factors. But in the case of with replacement, no need to use the correction factor. So you will get that the standard deviation of samples would be the standard deviation of population divided or over by the root of number of samples. Okay, the root of number of samples. So that is the formula of standard deviation. Okay, here we will calculate the mean of our samples. We have 10, 10. And you see here, you can try by yourself to prove it. We find here 6. If we go back, you still remember, here we have 6 also. Look at this again. The second times, we discuss a different problem. We can prove that the mean of population equals to the mean of samples. Okay, here, but not for standard deviation. For standard deviation, we will have this, You look here. By using this formula, you find here 2.01. And then, if you calculate by using a formula from me, a new formula, a shorter formula, you can see that you have this if you use the correction factors. So in this case, that means without replacement. The case is without replacement case. Okay. And also here you can see that the standard deviation of sample is not equal to the standard deviation of the population. Previously we have like 3.29 for the standard of this one, standard of population. It cannot be equals because we have this relation. The standard deviation of samples will be the standard deviation of population over the root square of the number of samples. Okay, until this, any question from your side, please? Okay, we can continue, Remember, always central limit theorems. It is explain us that the samples mean distribution will approach to a normal distribution regardless of the original form. If the number of samples greater than 30, or if the numbers of samples large enough. The meaning of large enough in statistics would be greater than 30. So that's why, for example, we want to select the number of panelists, or we want to make experiment, we should try that the total number of our samples should be greater than 30, okay? So then we can say we have a large number of samples, and we can have a high probability to perform a normal distribution, okay? That is the idea. And what is normal distribution? You can see that the normal distribution is that the distribution that has the peak of the chart exactly as the mean of the distribution. Okay. What happens if we have the chart when the the peak of the chart would be the mean of distribution, you can see that you will have equal value between the left side of the mean and the right side of the mean. You will have the same, or we can say that is a very fair condition. If we reduce the number of samples, you will see that we will have you will not have the peak of the chart at the mean. You can see that you will have different area from the left and the right side of your mean value. Here, the second condition, when you have, give attention to this, yellow. If you want to see this, you will have different form between the left side of your mean. You have different here. Or we can also say that probably if you try to find the mean value, then the mean is not on the peak, but your mean value would be somewhere here. Your mean value, exactly the mean. The mean is here. We expected that the mean value would be on the peak. This one is expected mean value. This one. The red one is like mu expected. But then the real one we have here. That's called then we cannot get the expected value. Last week, I think we already discussed that what is expected value. In theory, the expected value would be a mean, okay? So in this case, you will not have that expectation. You will not reach that expectation, That's why try every time to have a large enough number of samples. One approach is try to make samples bigger than 30, Okay, we continue. I have for you the next examples. We have 500 metal molds, About 500 metal molds have a mean weight. So average of weight of this metal mold from 500, 5.02 Newton. So we can say that you have population of 500. And now you have the mu of this population is 5.02 Newton. In this case, you have the unit of Newton. And standard deviation is 0.3 Newton. Okay? And the problem here, what is the probability that a random sample of 100 mold selected will have a total weight between 496 Newton and 500 Newton? So in this case, you will have the next information that the number of samples is 100. And the total weight you should consider is from 466 to 500. So you can here elaborate. Oh, here is the mu x1 is 466 over 100, 4.96 Newton, and for mu x2 you have 5 Newton. Okay. We asked about this problem. Okay. So now let us find the solution. After we understand, oh, the mu of population is 5.02 Newton, we know also the mu of our sample is also equals to 5.02 Newton. Okay. The deviation of population 0.3 Newton. The number of samples 100, the number of population 500. So we don't need to find the mean of we already find the mean of samples, yeah, that equals to the mean of population. But we should find the deviation of the samples. Follow the formula here that we have this formula. The deviation of samples equals to the deviation of population over the root of number of samples times by the correction factors. And then we have here the new information that the deviation of our samples would be 0.027 Newton, yeah? Okay, Newton. Okay, now the question is about what is the probability, yeah? What is the probability that X have the average, yeah, of week 5 and bigger than 4.96. This is Newton, eh? Newton. This is our the question, eh? We want to seek what is the probability that we have the metal mole which the average weight less than 5 Newton but greater and equals to 4.66 Newton. Now, here we can use our normal distribution, yeah, to find this. And you can find these normal distribution tables in appendix of your statistic book, yeah. And of course, for this, you need to find the z-score, this z-score. The formula for z-score is the mean, yeah, the mean of samples the X bar here, eh? This one is the X bar we have. Okay, so I can use this X bar. This is X bar 1, this is X bar 2, eh? Between this. So the difference between our problems, eh? Our problems and the mean of the sample we have. We have already the mean of our sample is the same of our population over the deviation of the samples. Okay, because we have this, then we can find the z-score for this. For this case, the z-score is this, 4.66 minus 5.02, and here 5 minus 5.502, and you get this one to be minus 2.22, and this value would be minus 0.74, okay, from your calculation, normal calculation. Just try by your calculator, eh? And now we already have this. We have this. To determine this, we need the information from our tables z-score, eh, for distribution normal. And you see, if you want to find the probability of this value minus 2.22, try to find minus 2.2 here. And then to have this value, minus 2.2 plus 0.002, right? Okay, look here. So you will have minus 2, 2. That's why here you use this. Then you see you will find this here. Put this to your calculation, eh? And now we want to see the second one, 0.74. The same way, eh? 0.7, where is it? 0.7 and 0.004 here. Okay, so we have the value of 0.0132 and 0.2276. This we have already. And from this, we can see here that the probability of X samples to have the weight between this, between 479 and 5 Newton would be the difference from this probability, and then you will see here the result of this 1.2164 and 1.2164 we multiply by 100% because 100% is 1, we have here 21.64%. So we get down. Okay, the mean value of the metal mole we have is 502 Newton. But we still have, because the deviation is 0.03 Newton. If we take the sample, the sample of 100 metal mole, 100 moles, the probability of us to have metal mole with the average weight of 4.3625 Newton, to 5 Newton, we still have about 21.64%. That is the story. Okay, you see, it is very interesting that statistician, we can find or estimate that probability following a very logic procedure. So probability is not something unlogic. I remember Kevin question last week, I think you still think that probability is not logic. Probability just happen. No, as statistician, you see that probability is something that is very logic and very, very structured. You can see here that you can always calculate the probability. And it is very interesting that Allah give us the probability. That means Allah is very fair for us. One of Asma'ul Husna, Allah is Al-Adl. He is the most fair. Allah is Al-Adl, Maha Adil, Al-Adl. So probability is very fair and a very logic things. And if we have a negative probability, that is not fair. And Allah always give you a positive probability. That is the meaning of this logic. Very logic. Okay, for this, some question, please, if you want to ask. Until this, do you have question? Okay, let's see. 1.1 × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ No, if you have, just raise your hand. Okay, now the last from me, the proportion distribution of sampling. What is the proportion? Now we have a new terms, proportion. Proportions, we can use here P. So the mean of proportion equals to the P, the proportion. P, yeah? We say this P from P, this is P. So the the mean of proportion would be that proportion, the proportion itself. And again, what we have is the difference in standard deviation proportion. In the case of sampling without replacement, you have this value that the standard deviation of proportion would be the root of proportion times to the theta. And what is theta? Theta is 1 minus proportion. Okay, theta is 1 minus proportion. P is proportion. Okay, so then here you see that the standard deviation of proportion would be the root square of P times 1 minus P, okay? Because here you see P times 2 theta and over N. Only if you have the case of without replacement, remember the factor correction again. So you have to multiply this value by factor correction. And then when we want to transform the proportion value to z-score, we need also to again to multiply the proportion to 1 over 2n. Okay, this is the factor correction. The second factor correction to transform proportion value to the z-score value. Okay, only this. Remember this factor correction if you have without replacement condition in your sampling method. And again, when you want to have a z-score, you have to use the second factor correction, that is 1 over 2n, okay? Only that. And we can discuss the last exercise here, yeah? Exercise 4, The Quality Control Department of Machine Tool Factory report that 2% of the drill bits produced are defect. So you see here we have 2% defect. And it is the case of proportion. The sign of proportion case if they give you the information in percentage. Yeah? If a batch of 400 drill bit is shipped, determine the probability that the number of drill bit with defect is 3% or greater. So it is very interesting to discuss. Look here, you have P is 2%. 2%, that means O02, okay? And then if a batch of 400 drill bits is shipped, now we have the N is 400. Determine the probability that the number of drill bit with defect is 3% or greater. So what is the possibility to have? To have the drill bits, yeah? The drill bits, that is drill bit, we can say X, yeah? Here, that has defect greater than 3%. That is our question. What is the probability? Okay, we can answer together here. The first one is mu p. We have the same as p. And we have here 0.02. 0.02. And now we want to calculate the standard deviation of P. And we have here, that is the P multiplied by 1 minus P over N. So you know, you have already, so you can calculate. Here you have 0.02 multiplied by 1 minus 0.02 over 400. Try to find by yourself. You will have here 0.007. Okay. And then the question is, what is the proportion that the drill bit has a defect greater than 3%? So the X here we have is 3%. 3%. And remember, 3% is the same as 0.03. And in this case, we want to use a normal distribution and to find the Z-score. And it is stated previously that we have to use factor correction to this value. So we can say here we have to correct this value 3% to the value of 1 over 2n. And then we have here 2003 minus this, 0.00126. And then we have the result of this 0.02875. Okay, that is. Okay, now we have all information. Try to find our Z-score. Our Z-score, previously we can write like this. We want to find the probability of X that is bigger than 0.02875. Okay, then we can change this, we can change this statement to be 1 minus P, where the P is less than 0.08275. And then we try to find Z-score. And remember the Z-score formula is the X value we have to P and to the deviation of P here. So you have here the X is our new average is 0.02875 minus to P we have 1002, and we have also the standard deviation of P that is 0.007, and you get here 1.25. Okay, so we can put a new statement that we want to seek the probability that is 1 P at Z-score at Z less than 1.25. Okay. So then you need the table. You have, I don't know if we can use this table. Previous table 1.2, 1.2, and 5. Look here. Here, if we use this table, 1.2, but this one is minus, look, and we have 5 here. So you have here like 1.1056. 1.1056. Okay, but we get it directly, if we change again, if we change again, but if you are using the positive value, the positive value of z score 1.26 is 0. I cannot see directly. 0.00894. But we have formula here 1 point. And 1.0.08944 would be 1.1056. Okay, you get also, and if you times this by 100%, you get the answer that the probability would be 10.56%. Okay, if you use the negative, the negative chart, the negative table, you will find this value, and also remember that the statement would be this. But if you want to use negative value, you can directly change it. That is equals to P equals to directly, P of Z minus 1.85. We get directly from the table 0.1056. Okay, I don't know if you feel this interesting, answer that using the last slide about distribution of proportion, you can also define the probability of a case, in logically, okay, accurately. And if you ask me how many percent, let me say how many percent the accuracy of this, yeah, it is about 5%, or the let's say the confidence level is 5%, then the chance of us to have accurate calculation is about 95%. It's very big, Okay, and also remember that the distribution of differences and sum of sampling following this. For the mean value, if you have two samples, if you want to see the differences between these two means, just look to the differences, the formula for the differences is the means of sample 1 minus the mean of sample 2. But if you want to see the total of means, then just add the mean of sample 1 to the mean of sample 2. However, in case of standard deviation, for both case differences and counts, you have the same. You have the same formula, that is, in both cases, the distribution of differences and sum of two samples would be the root of variation of first sample add by the variation of second samples. So remember that, you have this case in term of mean, but you have this case in term of standard deviation. And I have a homework for you. Please try to solve this problem. And again, you can collect your paper. Submit your paper to me. Not submit it on e-learning, but submit in hard papers. Okay, that's all from my side. If you have any question, you can ask me, please.
Ma'am, I want to ask about the homework. Um, when we will collect this homework to you?
I think you can submit this next week. I give you
Okay,
1 week.
ma'am.
Okay.
Okay, thank you, ma'am.
I have also recommendation that you can again attend a regular class if you have times. Just go to your regular class to solve our problems last semester. I want that you are in international class would have a better grade than the student in regular class. But if you have the problem in English, my recommendation is just try to attend the class 2 times. You attend international class and then you also attend the regular class. That is my suggestion. However, the teachers for the next meeting in international class uh, will be different from regular class. I don't know what will happen then. But for my case, I attend 2 times in regular and international class. However, we have the same course outline for both class. Just the teacher is different. Since Mr. Bambang cannot teach you in international class. Okay. Okay. And how is your feeling today? Are you okay? Some of you confused or sick because of me? Is that the case? Are you okay? Are you sick? I want to see you. How is your condition after listening to English class? Are you sick now? Somebody sick because of English class? No, I think you are strong, right? If somebody sick, you can show up. How is your condition? We talked already about 1.5 hours, 1.5 hours already. How is your condition? Uh, Sparkling in your head, or what happened? Nice or not nice? Berliana, how is your condition now? Good? Sick? Headache?
Tunggu, tunggu. Yes, ma'am. I'm good, ma'am.
Good? Okay. Because I know you forced to be in this class, but again, I said to you that is an opportunity, a good probability for you to improve your English. Even you are forced, to be in the class, and then because of that forcement, you have a probability to improve your English, and your probability is always positive, not negative. So the chance for you is to improve your English, uh, and maybe your improvement close to 0. But I hope your improvement close to 1. So you have a significant improvement then. But if you just attend with lazy, with sickness, yeah, maybe at the end you have no improvement because your improvement is so a little close to zero. Actually, we give you a positive opportunity to improve your English. So be positive as human being if you want to success. Okay, then uh, I prepare also Kahoot for you again. And Kahoot in Indonesian, yeah, because I don't have time to change the question. Oh, sorry.
Mak, na bakit?
Okay, student, thank you very much for your attendance. And now let us look to our result of our quiz. Okay, we can see here that active student with number 31 can finish with 88%. And here we can see only, oh, some of you cannot finish, yeah? Then 50%. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of you, 9 of you cannot finish the exam well. So my conclusion is that 50% of you can follow my class. Okay, so you see that you need to improve your English. But maybe because your level is different among others, you have to try by different way to how to improve your English. Okay, that is our problems. And again, I want to remind you that it's up to you actually how you face the problem. The problem is that you are forced to be in international class, not by your own choice. That is your problems. But after having a problem, we have a positive opportunity to be success or to not success, yeah. So then, following statistic, logical thinking, I hope you can use this chance, for you, Each of you have the same chance to be passed in the class, or to improve your English like that. The probability, by random sampling, each of you have each of you has the same chance. So then again, you should think by yourself, what is your problem. And for me, I record also my teachings. So and then I will upload this in my YouTube channel. You can come back to my channel and watch again the video. I hope, for example, from this moment, you listen to me and then you can answer like 50% of my question. And my question is in Indonesian language, yeah? So I hope that you can pass this Kahoot better actually because of the question in Indonesian. Okay, so today only 50% of you can pass. But after maybe you watch my video in my YouTube for the second, the third, or the fourth times, maybe we can play Kahoot again. I hope we can improve your condition. That is the way, yeah. I'm waiting you in WhatsApp groups, yeah. After you watch again the video, maybe we can repeat Kahoot to improve your quiz score, And today is also my last chance to meet you. I promise to prepare my English video for the first, second, third, and fourth meeting. So we will have a complete English meeting with me. But I make it like shorter, because I have no student in recording. So I will maybe have like a video of presentation from 5 to 10 minutes only, very short, But I hope then it help you to improve your English, only that. And also in the case you have a problem also with the quiz score in last meeting, we still have the chance to repeat that quiz. Okay, I'm waiting for you, and also I hope to meet you somewhere, not in the class. And just speak English with me, okay? I invite you to speak English. You can also speak English with my children, They are speaking English too. And it is a very interesting way to improve our English. And hope you enjoy our class, next class with Mr. Indra Sakti and also Mr. Professor Agus Arif Munawar. Okay, see you again. Thank you very much. don't forget to study hard ya. Oke, billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Waalaikumsalam
wabarakatuh.
warahmatullahi wabarakatuh. Warahmatullahi wabarakatuh.